Hello there, welcome to my YouTube channel. I am glad to have you, and in today's video we shall be providing solution to the question right here in front of me. I received this question from one of my students who is preparing for an examination, and I thought it would be nice to make a video about it. Do you know why? I tried searching online for some names. To be honest, the name of this compound, okay. So I found out that the solutions provided to this question, this particular question online, it's very wrong, okay. And so many people are just they will just copy it right there, and they won't even bother about solving it on their own. So I think it's going to be nice to make a video about it. So if you like this video, please feel free to share it with your friends. Please like the video, subscribe to my channel, come back again for more and more and more videos, because we are going to make a whole lot more. And say you have any chemistry related question that you are finding a little difficult to solve, feel free to send it to me. I will try my best to provide solution to it, and maybe I'm going to make a video about it just like this. All right, okay, with that out of the way, let's begin. The question reads thus: the solubility of Na3ASO4 H2O12 is 38.9 grams per 100 grams of water. What is the percentage of Na3ASO4 in the saturated solution? And the atomic masses of arsenic, sodium, oxygen, and hydrogen were given. Okay, the name of this salt is sodium arsenate dodecahydrate. Good. This is a solubility related question, and solubility is defined as the maximum amount of a solute that dissolves in a given amount of solvent at a specified temperature. In our case, the solute is sodium arsenate dodecahydrate, solvent water, and the solution is the 2. Good. Before I begin, or anytime I get to solve any chemistry related calculation question, I always begin by writing out my parameters. Whatever is given to me, I call them the knowns. I put them down. So let's do it now. Let's do it right now. Good. So Na3 ASO4 H2O12, its mass is given to be 38.9 grams. That, my friends, is the solute. The solute. I'm going to put it right here. Good. Then the mass of H2O is given. H2O is what again? Our solvent. Okay, so when you put solute inside the solvent and both dissolves, what do you get? You guessed right, a solution. So our solution is the solute plus the solvent, okay, which in our case is 38.9 grams of the dodecahydrate salt and 100 grams of water, which gives what? 138.9 grams. Good. Now let's go back to the question. What more do we have? Let's read. What is the percentage of sodium arsenate in the saturated solution? And the molar mass, the atomic masses of this elements were given. Okay, now from these values we can calculate the molar mass or the molar masses of this and this, right? Yes, we can. Yes, we can. So let's do that right now. The molar mass of Na3, okay, follow me. The molar mass of Na3 AsO4 H2O12 can be calculated, and that will be 3 multiplied by 23. 23 is for sodium. We are multiplying by 3 because there's a 3 right here. Okay, good. And then arsenic, we have 75. Oxygen is 16. And water is what? Hydrogen is 1. We have a 2 here. So that's going to be 2 multiplied by 1 to give 2. Okay? Plus oxygen is 16. 16 plus 2 gives 18. Good. So we are multiplying 18 by 12. The multiplication and the addition of these values will give us what? Give me a minute while I do that. It gives 424 grams per mole. Nice. Now, what else can we calculate? We can calculate the molar mass of Na3AsO4, right? Yes, we can, of course. So, what do we have? 3, this 3, multiplied by 23, plus 75, plus 4, multiplied by 16. That is going to be what? The answer is 208 grams per mole. Sweet. Now let's go back to the question. What is the percentage of sodium arsenate in the saturated solution? We are looking for the percentage of sodium arsenate. Now, Na3AsO4, its mass is not given, is it? No, it's not. Okay, so we have to find that. The reason why we need to find that is we are looking for its percentage in the saturated solution, and for us to know the percentage of these Na3AsO4, the sodium arsenate salt, we have to know its mass. All right, good. Now, how do we calculate the mass of sodium arsenate? I am going to use a formula. The formula is mass of anhydrous salt divided by the mass of hydrated salt equals the molar mass of anhydrous salt divided by the molar mass of hydrated salt. Formulas are going to make your life very easy, very easy, especially if you are preparing for examination. So I will recommend that you know this formula. It's very easy to know, right? Mass, molar mass, mass of anhydrous over mass of hydrated equals molar mass of anhydrous over molar mass of hydrated. The mass ratio of the anhydrous salt to the hydrated salt must always be equal to the molar mass ratio of the anhydrous salt to the hydrated salt. Okay, thus the mass ratio must be equal to the molar mass ratio. Simple, easy, sweet. We're going to proceed now to determine the mass of sodium arsenate using this formula. We don't know this, we know this, right? This is it. And of course we know this, which is this. Alright, now before we proceed, please feel free to share this video with your friends. Please like this video, subscribe to my channel. I will like it very much. Please come back again to watch many more videos that I will share. Alright, good. Now let's proceed. The mass of anhydrous salt, we don't know. The mass of hydrated salt, yes, this is it, 38.9. The mass of the molar mass, beg your pardon, the molar mass of anhydrous salt is this, 208, and the molar mass of the hydrated salt is this, 424. So the next step is to do the cross multiplication of these values. So we are going to have what? The unknown multiplied by 424 gives 208 multiplied by 38.9. Alright? So our unknown is going to be what? 208 multiplied by 38.9. Beg your pardon about that. 208 multiplied by 38.9 divide by 424. Okay, so let's do that right now. 19.08 grams. That, my friends, is the mass of the anhydrous salt. 19.08 grams. Sweet. Now, what can we do? Let's go back to the question. What is the percentage of Na3ASO4 in the saturated solution? To find the percentage of anything, it's very easy, right? Just do the mass of this, divide by the mass of the saturated solution, everything multiplied by 100, right? Yes, so let's do that right now. Give me a minute while I wipe the board. And while I do that, please like this video, subscribe to my channel, come back again for more. You are going to get the best from this channel, because you know what? You, my friends, are the best. Let's go back right now. Okay, now the percentage of Na3ASO4 will be equal to the mass of Na3ASO4 divided by the mass of the saturated solution, all multiplied by 100. Okay, the mass of Na3ASO4, the sodium arsenate salt, is this, and then the mass of the saturated solution is this. So my friends, we have 19.08 divided by 138.9 all multiplied by 100. So give me a second while I calculate that. Good. So the answer, which is the final answer, is 13.7%. Before we go, I would like to test our comprehension, because you know what, it's very easy for me to solve this, but the real task comes in when you get to do it on your own. I have a question for us that I would like you to solve. It's a slight modification of the question I just did. So this is it. The solubility of sodium arsenate dodecahydrate is 19.5 grams per 100 grams of water. What is the percentage of sodium arsenate in the saturated solution? And the molar masses of arsenic, sodium, oxygen, and hydrogen are given. Please, I would like it if you can put your answer in the comment box. Alright, let's make it interactive. Put your answers in the comment box. Like this video, share it with your friends, and then subscribe to my channel. And I will see you in the next. Cheers.